Dr. Zachary Moore, thank you very much indeed for coming back on to Talk Beliefs. You are a medical writer and have a PhD in molecular biology. And of course, we know you from the popular Evolution 101 and Apologia podcast. Did I pronounce that correct? Apologia or Apologia?
No, actually, you pronounce it correctly. I pronounce it incorrectly. I pronounce it Apologia, which I know is incorrect, but I like it better. So.
Yeah, and they are still out there for anyone to download. I recommend them to anyone. Last time we talked about the fact and fiction surrounding the topic of evolution, and we're going to dive into those turbulent waters again now with this interview. But first of all, let's catch up with what you've been doing since our interview in 2017. Any new projects you can reveal?
Yeah, actually, so it's just been announced that I will be a speaker at the American Atheist Conference this year. It's being held in Cincinnati, Ohio. So I am very much looking forward to that. I'm planning on giving a kind of a retrospective talk on my more or less the past decade or so that I've spent engaging with Christians, especially evangelical Christians, and kind of taking stock with all the things I've learned along the way, what I think are the sort of the best lessons we can apply to being an atheist in America in 2019 and beyond from that experience, and just sort of reconnecting with the atheist community that's out there. And I think it's fantastic. I'm originally from Cincinnati, so I thought it was really cool that I got that opportunity to join that group and be a part of that event in my hometown.
Okay, so on to
evolution,
yes. The evolution, as sometimes they tell me it should be pronounced. Well, it's been around for a long time, 150 years. It's used in the science and medical world every day. There are many institutions that are grounded in evolutionary science, and yet there is this huge pushback from some people, usually, but not always, religious creationists who insist that the science is wrong and that it can be easily disproven. So what I've done, Zach, is to compile a list of what I call creationist gotchas, criticisms of evolution, how it works, the methods used, etc., that come up over and over again that I see a lot. So I thought we could go through these one by one, and then maybe we could clear up any misunderstandings surrounding the subject. What do you think?
Sure, no, absolutely.
Okay, so I have to get this one out of the way first. Evolution is just a theory.
Just a theory, yeah. So everything in science is just a theory, right? So what is that's sort of the goal in science, is to develop a workable theory, right? So what this really comes down to is a bit of semantic confusion, right? So there's the theory, there's the word theory as it's used in the kind of a technical way within the sciences, where it's a very, very strong sort of a framework, an intellectual framework, understanding how to explain a certain set of phenomenon or some aspect of the natural world that is very well attested, very well evidenced, has passed through peer review many, many times, usually reflects the consensus within the field. Sometimes there are some competing theories that are also very, very well evidenced and attested and have good reasons for them. And usually what happens in science is when you have one theory that's very well evidenced and another one that's very well evidenced, usually what ends up being the case is there's some synthesis of them that is figured out that makes sense. Sometimes you can't quite do it. Like with in quantum theory, there's the idea that photons, for example, behave as waves, propagate through space as waves, but they also can be measured like particles, like shooting across. Yeah. And there's good evidence for them acting as waves. There's good evidence for them acting as particles. We don't exactly know yet how to explain that. There's sort of a quantum field theory that I don't fully understand, but if you're curious about that, look up Sean Carroll on YouTube and other high-level physicists that are trying to explain how these things can be true at the same time. And quantum field theory very well may be, and I think it is, according to Sean Carroll, the best explanation that we have now, which is a much better theory.
We're talking like a capital T theory here, aren't we? In a
Yeah,
sense.
capital T, or a theory. I don't want to say in quotation marks because that makes it seem like not really a theory. But what I'm trying to say is there's a difference in the way that theory is used by scientists and the way most people use it. Most people, when they say theory, they're like, well, I have a guess about something, or I have a theory about where the cookies went. Or,
A hunch.
an educated guess, a hypothesis, you might say, where you could, anybody could come up with a theory, without any training, without any evidence. It's just, sort of a gut instinct sort of a thing. That's typically how we use the word theory in common parlance, you might say. But in science, it's very different. So to say that it's just a theory, you're conflating two different senses of the word theory. And if you were to say that to someone who's any bit of scientific training, you sound a bit ignorant.
Yeah, so literally, if you look it up, there's two definitions. There's the theory which you first described, or the capital T theory, and then you have the hunch or guess, which is the everyday use.
Yeah, so you're totally confusing the two concepts.
Okay,
if you do that.
Right. We're going to move on to the next one. Show me an example of a kind turning into another kind. I think when critics say this, they are thinking of some weird, I don't know, half cow, half alligator creature, but what they're referring to are transitional forms, correct?
Yes, I think that's what they're saying, but maybe not. So first of all, what they're talking about, this concept of kind. So we just talked about this word theory having a particular scientific connotation. The word kind has no scientific connotation. The word kind, it's used in the Bible, in the Old Testament, to refer to different sort of categories of animals, but it's not entirely clear. Like there's absolutely no mapping of the concept of kind onto what our current taxonomy, our current biological taxonomy.
Yeah, is it phylum or order or what?
So nobody knows, and I've asked that question to creationists who sort of push that, and they don't really know. And it seems like it sort of depends on whatever the situation is. So if it works to their advantage for it to be phylum or order, or even family or genus, like one example is they talk about wolves and dogs being of the same kind. Well, but wolves and dogs are different species, right? They can interbreed, but they are different species. You recognize them as different species, and they've spent at least 12 millennia speciating from each other, right? And you cannot tell me that you take a wolf and you take a little chihuahua, right? And you look at the difference there, right?
Yeah.
And so they're saying, well, they're of the same kind. Well, look at the amount of change that we've been able to produce between a wolf and a chihuahua over, it's probably many millennia, but let's say it's only 6, according to the young Earth creationists. That's still a tremendously fast evolution of form. I mean, whether you believe that they're a different species or they're the same kind, you cannot.
Dogs are artificial selection, aren't they?
Right,
they were bred by man.
Right, but that's the point. Like, and that's the very same point that Darwin made. So Darwin, when he started his book on the origin of species, he started on, or he described the process of artificial selection as a way of sort of familiarizing the reader with, oh yes, of course I know that animals can change their form over multiple generations according to certain pressures, right? Of course everybody knows that because we've done that with all the animals that are in our lives. So the inference that Darwin was making was, well, what if nature can provide the same selective pressure? Like, wouldn't it, like, we already know that forms can change over time, along generations. What if nature was putting pressure down? And so what creationists do, who want to talk about these kinds, is say, for completely artificially of their own, that there is some sort of a dividing line beyond which you cannot change something any further. Well, if you can change something from a wolf to a chihuahua, You know, imagine changing a Chihuahua into something just as further from a Chihuahua as a Chihuahua is from a wolf, right? Now, imagine that thing. Is that thing going to be mating with wolves at all? You know,
Yeah. It
I
might
don't,
be a
I don't
case
think
of
so.
they can, but they won't. In some
Well,
cases.
Chihuahuas probably can, but they won't either, right? So we're already to that point. I mean, can you imagine a wolf and a Chihuahua? It's ridiculous.
I
How
don't
would
want
that
to.
even work? Yeah, I mean, just clear that out of your head. But the point being, and the other side of this is also that we don't really have a consistent, maybe philosophically tight definition for even what a species is. In part because the boundaries between groups of organisms, populations, are so fluid and so gray. They're constantly bleeding over from one into the other, that it's very difficult for us to draw a bright line between two different species. Now, we do, because as human beings, we have a desperate need to categorize everything. And so we look at different groups of animals and we say, okay, well, this is a type of this is a type of that, this is a type of this. But there's loads and loads of examples within the natural world of what is very obviously one species blending into another species. And you know, so what do you say to that, right? So there's the example of the ring species, where you're either progressing across a linear distance, or you're sort of going around some
An
sort of a
island or
big
something.
object, or a mountain range. And all you would have to do is eliminate one of the subspecies that's in the middle of that progression, and now you've immediately got two species. Well, what is that, right? Is that speciation in process, or is it just still one species? When that subspecies dies, do the categories completely change? We don't like thinking about that because our brains like these categories to be static. We don't like the idea of them changing. But the natural world doesn't give a shit about our psychological comfortability, let's say, and very often challenges us. And so, you know, you look at species, and species do not fit into tight little categories. Certainly not in the way that kinds do, which are even more. It's a more clumsy and crude. Which, of course, why wouldn't it be, right? So this concept of kind goes back to the Bronze Age. Why wouldn't it be clumsy and crude? Why would we expect it to be anything else? Well, because it's the Word of God, right? And so God knows everything. God is perfect. God can make right. So this is the creationists find themselves in this deductive trap, where they have to believe that God is perfect, and they have to believe that the Bible is the literal word of God, and therefore they have to figure out how whatever they read in there makes sense with the natural world. And it's a very hard thing to do, and they do intellectual somersaults about it all the time. And it's not just the Christian creationists; the Muslim creationists are just as bad.
Yes, I've spoken to them in the street about the same thing. Yes. It's very similar.
Yes. I encountered Muslim creationists very, very early on when I first started engaging with Christian creationists, and I was floored by how the way that they argue is exactly the same, but they're using completely different scriptural proof texts. And they would, if you put two of them together, they would completely argue with each other about what the theological implications are. But they know that they have to make it so that evolution cannot be true. It's one of those things where you go from one bubble to the other and you see, okay, it's a similar process.
Okay. Along similar lines, there should be millions of transitional fossils. I hear that a lot.
Well, of course there are, right? Because in one sense, every fossil, every species that exists is a transitional species, right? So if the evolutionary process is one that it's constantly working, right? So it's constantly evolving. That does not mean, however, that everything is always changing. Like every species changes a certain amount, 0.1 evolution units per generation. That is not the case. There are some species that move into an evolutionary niche or an ecological niche, and they do very well there. and they don't really need to change, and there's no pressure for them to change at all. So you get species like crocodilians,
sharks,
turtles haven't changed much. I think the tuatara lizard, there's some sort of a marine iguana-ish lizard, I think is it Australia or New Zealand, that hasn't changed.
Have to evolve,
right? So the process is constantly active, and there is constant refinement, let's say, of the species, right? So whatever the ecological pressures and natural pressures are on the species, on the population, will continue to be the case. And if those change, then we see radical changes in the groups of species as well. Either they go extinct, right, or there's some subgroup, some population that adapts within that, or there's some other species that moves into that niche, right? So you might have species A go extinct, and species B, which has been nothing up to that point, moves into the niche now because of some other change that gives some advantage to them.
Like the rodents who took over from the dinosaurs, basically became us.
Yes, and the rats that will probably take over after us.
And cockroaches.
And cockroaches, yes, exactly. So that being the case, though, again, the idea of transitional fossils is one that we are forcing on the fossil record because of our incessant need to categorize things. So we look at certain types of fossils and we say, okay, well, this is a swimming population, and then we look at this other one, we say, well, now this population is walking around on dry land. So this is the dry land group. This is the ocean group. There's got to be some transitional form between we've just created those two groups just by thinking about it, right? So we're categorizing constantly. That being said, you can find those intermediate forms, right? So one really great example of a fantastic transitional form is Tiktaalik rosei, which was found by Neil Shubin.
Neil Shubin,
yeah. And it's a transitional form between exactly what I was just saying, between swimming organisms like fish, kind of. They existed in kind of shallow seas. He found it on Nunavut Island in northern Canada in the Arctic Circle. So that area used to be tropical and was a shallow tropical sea of sorts. And based on the geological evidence that had already been characterized for that area, he predicted, well, he and his colleagues predicted that there should be some fossils there, some species that were preserved there that probably lived in both water and land. And he went there for many, many years, and he finally found exactly what he was looking for. And it was a prediction that he made based on the geology of the area. And
Devonian deposits, is that right?
Yeah, I think that's right.
Yeah.
And it's a fantastic specimen that he found, and it fit perfectly right into exactly what he was looking for. It's a fantastic success story in science, in science in general, and in evolutionary biology specifically. So anybody who's interested in that, I recommend you read Neil's book, Your Inner Fish, which is all about that, and it's really fascinating.
And there is a TV series, isn't there? A miniseries
that he did for PBS. Yeah, I think
it was.
So.
Yes.
Yeah, there's an adaptation of the book. Yeah.
Okay, next one. Radiocarbon dating is inaccurate. Now, critics will say that paleontologists will date fossils by using a kind of circular method, that they use the fossil to date the rock and vice versa. So how can we clear up the confusion here?
So with radiocarbon dating, that has limited uses. So carbon being an element that you really only find in living or recently living things, right? So, but there's a whole range of other radioisotopes that you can use to date all sorts of things, polonium for one. But the confusion here is really, I think, it goes back to like just being ignorant of history, I suppose. So yes, it is the case that you can look at the different layers of rock, and you can find the different fossils in there, and you can date the fossils by what layers the rock's in. You can also help date the layers of rock by what fossils are in there. But that's not how it happened originally, right? So Originally, the characterization of the different rock layers as modern geology, right? It actually preceded evolution, right? So the main person who was responsible for our modern understanding of geology was Charles Lyell, who wrote, I believe it was called Principles of Geology. Now, he was friends with Darwin. He knew Darwin, but he did this before Darwin came up with his theory, right? In fact, when Darwin went on his trip, his voyage on the Beagle, he had a few possessions of his own with him, one of them being Lyell's book, right? So he was, I don't know if you would say that he was a student necessarily of Lyell, certainly not formally, but he knew of the different geological layers, and there was already, before evolution, before you start looking seriously at these fossils as evolutionary traits or evolutionary forms, there was already an understanding that the world is very, very old. Right. So Lyell, he believed in sort of uniformitarianism. He believed in a very ancient Earth, and this was already opposed to creationist ideas about the world being formed in 6,000 years ago. And that has nothing to do with evolution, right? So that is purely based on his study of the rock. Lyell was from Scotland. He would, go up and down the mountains and he would see the different layers of rock there. I'm from Southern Ohio and Kentucky, where a lot of Scottish immigrants immigrated to. And it was always fascinating to me because they have sort of these rolling hills through Kentucky that's kind of similar to Scotland in a lot of ways. And they would cut these highways through. So in Scotland, they don't really cut through the mountains so much. They sort of go over them. In America, you just cut right through. And so when they built the highway system here, they cut through all these hills, and you can drive through the hills. You can see layer, 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 and it's right outside your door. It's right in front of you. You don't really have to go looking for it like Lyell did. But Lyell was very familiar with his countryside and the geography or geology of Scotland, geology of England. And just by making those observations, you could see that the same layers were in the same pattern. And assuming that, and of course, that certain layers of rock are laid down over time, right? Yep. So you have sedimentary rock that has to be laid down and then pushed up again, and that's kind of how you get to see the layers for the first time, is when the layers are buried and then they sort of erupt up from seismic forces or the tectonic forces pushing things up, and so all of that discernment and discovery about the geology preceded Darwin, preceded all of this. Now the paleontology kind of came about at the same time, because you did have, with all these people studying rocks, you had lots of people finding fossils, and what they found was, as they were studying the rocks, that we've just noticed that you never find this type of fossil in this layer, right? It's, and as they're going through and they're studying the layers and they're characterizing them, they're saying, yeah, this fossil is only ever found in this layer. Isn't that interesting? Well, and so that's how they can actually use the fossils, because now they've already known that. They've already characterized that. They've already figured out there are certain fossils that only exist in certain layers. So they can go to another site, and if they can't get a good read on the layer itself for whatever reason, but they're finding certain fossils that they know only exist in that layer, then that is an indication that, okay, this is the layer that we're dealing with here, right? So it's not a circular thing. It actually comes from the characterization of the geological layers that were in existence before Darwin even sailed on the Beagle, right? So it's not a circular thing at all.
Okay, how about this one? Most scientists have already dismissed evolution.
Well, that's just completely
or all scientists. I heard as well. Some of my comment section.
Yeah, that is completely false, right? So, just as a way of example here, or counterpoint, I can't remember which organization it was that did this. If it was the Discovery Institute or the Creation Institute. Well, one of them attempted this project where they would find as many scientists as they could and get them to basically sign a statement saying, we are skeptical of evolution. And they got a pretty good number of names, I want to say. Let's say 1,000 names. It may not have been 1,000, but let's say 1,000 names. And so there's another organization, a science organization, that said, okay, well, we'll do you one better. We'll have a different statement, and we'll offer it in support of evolutionary theory, and we'll get scientists to sign that. With the one caveat is we will only accept signatures from scientists named Steve. So the creationists got, let's say they got 1,000 names. The science group got 5,000 names of just scientists named Steve. They called it Project Steve. Wow. This was a while ago, but it was just a way of sort of illustrating the incredible imbalance in the scientific community, that it is overwhelmingly accepted. It is not even controversial scientifically, right? And that's not to say that there aren't controversies within evolution, right? So there are still questions, right? So if you are a scientist, the one thing that you learn as you study, as you explore, as you answer questions, is that every question that you answer with a research project creates 2, 3, 4 or more questions that you need to figure out, right? So that's why scientists keep on doing science, right? So scientists typically have very, very, very long careers. They almost never retire. They just keep going, because every time that they come up with some answer to something, they come up with even more questions.
I know that in paleoanthropology at the moment, they're talking about Homo habilis and these various hominids, that perhaps they were Homo erectus after all. I mean, that's the current thing, isn't it?
Yeah, well, human evolution is still, and we're finding more and more all the time, right? So it used to, I think when I first learned it, it was Homo habilis, Homo erectus, Homo melanogaster,
Heidelbergensis.
Yeah, Heidelbergensis, and maybe a couple more. And now it seems like there's 3 times as many, including Homo floresiensis, the Hobbit.
Yeah.
Right, which everyone in England should love.
And of course, Lee Berger found like a new species of Australopithecus and then Homo in almost a handful of years.
Right. And it's an open question as to how to what extent were all these species related to each other. Was the Hobbit actually? I think some people think that the Hobbit was actually a descendant from Erectus at this point.
Yes,
or they're not sure. So. Some people may have thought it was another sapiens. I don't know, but the point is that there's still loads of questions just about human evolution, and every and of course humans being humans, that's the thing that we all care about most. Nobody really cares about all these other species. Everybody wants to know, what about me? Are you telling me that a monkey was my uncle? Really? That's really what it all comes down to. Is
they take it personally, in other words.
Yeah, it all comes down to our own anxiety, our sense of value. If you're telling me that I'm just an animal, that I'm just an ape, that I'm not valuable, I don't mean anything, and that's horrible, and I can't handle that, and so I'm just not going to listen to you anymore. But at any rate, so there are loads and loads of questions, and we're still exploring these things, and it's not really it's not a problem really for science. It's what makes science so interesting and so challenging and so rewarding, all the things that we're discovering.
Well, another one I hear a lot, Zach, is we don't have the common ancestor between apes and humans. And well, it is true, we don't, but that doesn't mean we won't.
Yes. So that would be the most recent common ancestors. Like, we do have a lot of common ancestors. So, you can go back, through the evolutionary history of primates in general. You can find, right. So all those species are ancestral to us. And in fact, there's a really fantastic book, what I think is probably the best book by Richard Dawkins. It's called The Ancestor's Tale. and he goes through our evolutionary history, and he identifies it's quite a large number, something like 24, let's say, common ancestors between humans and other clades of organisms. And
now,
sort of
clade is the branch on the tree.
It's a categorical concept. Again, this is us. We humans are our incessant need to categorize things. It's just a better way of thinking about how different species are related to each other. But so he goes back through the tree, through the cladistic diagram, and he identifies all the common ancestors that we've had and tells their stories. And each one of them are very interesting stories. So I would recommend, I think he says like maybe 1 or 2 insulting things about creationists the whole time. So it's really, he's on his best behavior through this book. So if you are a creationist and you find Richard Dawkins irritating, read this book, because it's fascinating. And Dawkins is, if nothing else, a master of finding really, really good metaphors to explore that help illustrate scientific points. And I think The Ancestor's Tale is really one of his best. Now, you are correct that the most recent common ancestor, so this would be whatever species existed that gave rise to both the chimpanzee clade, the Pan family, as well as the Homo family, us, humans and other hominids, other human-like species. Whatever that species was, we don't know. We don't have direct fossil evidence of whatever that species was. However, we know that there was one, right? So we can infer very confidently based on not just comparison of human beings and our physiology, as well as chimpanzees, both Pan-Paniscus and Pan-Troglodytes, to our physiology. We can compare our genes, and out of all the organisms that exist now, they are our closest relatives genetically. And so what that means is just like you and I, right? So, people might say, well, Mark and Zach don't look very much alike, but if we go further back in time, right? So if we keep on going, if I find my father, you find your father, my grandfather, your grandfather, and we keep on going, it's not a controversial thing. And everyone would probably expect that if we go far enough back in time, we're going to find somebody that you're related to and that I'm related to. Yeah. Right. It's not controversial at all. Right. And you can look at our features and say, well, maybe we look somewhat similar. Maybe we have, they would predict based on the way that we look that, you and I are probably more closely related to each other than perhaps to, I don't know, Denzel Washington, let's say, or Kim Jong-un. And then we could take our DNA and do the same comparison. And people would say, do you think you're going to find, how many generations do you think it's going to take to find a common ancestor between Mark and Zach versus Mark and Zach and Kim Jong-un? And people say, well, it'd probably be a lot sooner. Yes, exactly. Yeah. And it's exactly the same sort of process that we go through when we look at different species. We're doing the exact same thing. The only thing that we're not doing is getting all weird about our anxiety about being human and not wanting to think of ourselves being one of the other animals.
Exactly. Well, I'm afraid I saved the best one for last. So, what about the soft tissue recently found in a T-Rex bone that proves that dinosaurs only lived a short time ago? Now, this seems to comport with the biblical creation happening only around 4,000 years BCE. So, what do we have to say about that?
Well, first of all, soft tissue isn't typically preserved over 4,000 years either, right? So
exactly.
if that's what we're crying in triumph about, the soft tissue. Well, soft tissue that's 4,000 years old, that's easy to believe. But 60 million years. So actually, it was when they first discovered it was a big question, like how in the world? Because it clearly was preserved. Now, preserved with quotation marks. So it wasn't like you cut up in this bone and you smelled fried chicken.
Big
right?
chunk of meat, yeah.
Right. Now that being said, so they were able to. There were some proteins that were preserved, which is remarkable, and it was collagen, which was very cool. And they were able to compare the collagen, the structure of the collagen, the proteins that were there in order. They were able to compare that with other samples of collagen that they found, and in fact, the closest match was chicken. So it seems it seemed to confirm Gallus gallus, the chicken. It's a common genome that you use to test against. Anybody can test anything they want against the chicken genome if they want. You go to the National Center for Biotechnology Information, their website. But yeah, so in one sense, it confirmed what a lot of people had thought about dinosaurs, that their closest relatives still living, still extant relatives, not descendants exactly, not necessarily, but relatives, were birds. So, cousins at least, let's say. And so that does confirm that. Now, as to the soft tissue being preserved, so it wasn't fossilized, it was preserved. That being said, they from what I've read, they have a pretty good hypothesis as to how this would have happened. So the fact that it was bone marrow was significant, because so what happens, and they've done some experiments with like ostrich bones to try to do the same thing, is that when the animal dies, the blood cells kind of burst, and all the hemoglobin that's in there. Of course, hemoglobin is a protein that carries iron, so the iron goes free, and the iron apparently when it's when soft tissue is bathed in a bath of iron, or a very iron-rich material, the iron intercalates into the soft tissue and preserves it. Basically, it keeps it from being decayed and degraded. Yes. They've done these experiments with ostriches, I believe, and they've seen you can take an ostrich bone and sit it in like a kind of like a blood bath. Sounds kind of gross, but you could set it in a blood bath for like something like 2 or 3 years at room temperature, and all the blood vessels on the inside stay preserved. It's weird. Nobody would have ever thought to test this. Like, this is not one of those things that someone wakes up in the morning and says, I wonder what you would do, or what would happen if you started bathing organs in blood and just let them sit in my laboratory for 2 years. You think that would get past the research committee, the grant committee? No, not a chance. But because they've had this discovery, they thought, how do we explain this, right? So again, in science, this is not a problem necessarily. This is a question, and we have to answer the question, right? And so this seems like a pretty good answer that has been come up with. There might be more to it than that. There may have been, maybe other conditions. But we do know that most bones are not found with soft tissue. So whatever the case is, this is not something that is typical. So there probably were a series of special conditions that were necessary. That being said, as well,
perhaps the fact it was a large animal had something to do with it.
Yeah, that could be it. That being said, as well, these days we're finding a lot of paleontology being done in China, which is a country that typically has not had a very active paleontology community. But it's huge, and it's very geologically diverse country. And there's a lot of really,
isn't it?
Yes, there's a lot of really interesting, really cool dinosaurs with feathers preserved being discovered there. So who knows what else we might find in terms of fossils in the next few years. It'd be interesting, right? So, the larger point is whatever we find, it's not like scary, right? So, whatever we find is what we find, right? So if it's out there in the natural world waiting to be discovered, we're going to discover it. We're going to characterize it. We're going to incorporate that information with whatever we already have. So it's not like there's not some big concern about, well, we're going to find some fossil out there that's going to completely turn evolution on its head, right? So, and as if there could be a fossil like that, right? So the only thing that you could possibly do in terms of finding fossil, like if you found a fossilized human skeleton in a Precambrian layer. Okay, that would really screw things up. That would,
Yeah.
but it would still be interesting, right? You'd still want to know, okay, so how did this happen? What is, whatever the case is, we would want to, if there is something that is discovered that does kind of screw with the theory that we currently have, that's great. So we change the theory, you modify the theory, right? So whatever information comes in, you modify your theory to fit it, right? With creationism, it's the opposite. You start with this predetermined, vacuum sealed idea of how the world works, and you accept only those things that fit into it, and you reject everything that comes out of it. So anything that contradicts your view, your creationism, that gets thrown right out. You dismiss it, or you say, well, that was contaminated by this, that, or the other. And it's a constant sort of, it's a constant just exercise in reinforcing this bubble of anxiety that exists, because you're afraid that humans aren't special enough, and that if humans aren't special enough, you're not special enough. And it tends to be the people that just can't handle that, I think. Not to read too much into people's psychology, but this is kind of what I've seen. Like the type of people that really advance this are the type of people that I've seen, acting in such a way that is consistent with, just being very anxious, worried people about their own place in the world. And I understand that, but it doesn't make them right.
I think that's excellent, Zach. Thank you so much for that. And I'm sure I am going to compile some more of these gotchas, as I call them, perhaps over the next year or so.
Sure.
And maybe we can do this again, and I'll throw some more at you. What do you say about that?
Sounds great. Looking forward to it.
And great. And as before, I'll leave links to your website, the Twitter, the podcasts in the description below. And all I have left to say is, Dr. Zachary Moore, thank you very much for your time.
Absolutely. Pleasure, Mark.